All right, this is lesson 6.2.6 for 7th grade, titled, Is There Always a Solution? Here we go. Are all equations solvable? Are all solutions a single number? Think about this. Annika was born first, and her brother William was born 4 years later. How old will William be when Annika is twice his age? How old will William be when Annika is exactly the same as his age? In this lesson, you'll continue to practice your strategies of combining like terms, removing zeros, and balancing to simplify and compare two expressions. You will also encounter unusual situations where the solution may be unexpected. As you work today, focus with your team on these questions. What if both sides are not equal? Are there many values of x that will make the expressions equal? Is there always a solution? So 6-116 is our first problem. And there's actually a lot of parts to this problem, but it won't take too long. So it says many students believe that every equation has only one solution. However, in the introduction to the lesson, which I just read, you might have noticed that if Annika was 4 years older than her brother William, they could never be the same age. Some situations have one solution, others have no solution, and still others have all numbers as solution. So it says, for each of the following equations, reason with your team to decide if there is one solution, no solution, or all numbers are solutions. If there's a single number solution, write it down. If you're not sure how many solutions there are, have each member of your team try a number to see if you can find a value that makes the equation work. So here's our options. Our options are one solution, no solution, and all, I'm just gonna put all numbers are solutions. I'm gonna put sol. I'm gonna put sol a lot because I don't want to write the word solution out for the sake of time. Okay, so part A gives us this, x equals x. So if I looked at the equation x equals x, and I thought, well, what could x equal? Let me pick a number, 0. So if I plugged 0 in for x, it would also be 0 on the other side. What about the number 1? If I plugged in 1 for x, it would also be x or 1 on the other side. That works too. And I'm pretty sure that if we plugged in any number for x, we would have x on the other side, or we would have that number on the other side. So for this, for A, all numbers are solutions. Any number works for x. Any number, even a billion trillion would work. Part B says x plus 1 equals x. Now you might look at this and start trying out numbers like you could do -1 for x. So -1 plus 1 does not equal -1 equals 0. So already we're noticing some issues. So what I did is I drew a little equation mat to help me visualize it. And I put on the one side, I put an x plus 1 cube. And the other side, I put just x. So then I can do some of my strategies, or I can use some of my strategies to get rid of the x from each side. I can match them up and get rid of them. And then I'm left with 1 equals 0. And that doesn't make sense to me because the number 1 does not equal the number 0. So that means there is no solution. 0 cannot equal 1, so there is no solution here. No number you plug in for x will make that equation true. Part C says x equals 2x. So I started plugging in some numbers. So if I did the number 1, x would be 1 equals 2 times 1. 1 equals 2 does not work. So 1 didn't work. Based on that, I tried 0. 0 equals 2 times 0. So 0 equals 0. Hey, 0 works. Sorry, that's a check. 0 works. And I'm thinking to myself that that's really the only number or value that would work for x is 0. Because if you multiply, say you use 4 equals 2 times 4, 4 equals 8, not true. So for this part C, one solution, x equals 0. Anything times 0 will always give you 0. All right, part D. X plus x equals 2 plus x. Whenever it has all this stuff going on, it kind of messes with my brain, so I have to draw an equation map. I'm going to draw one right here. So I'm starting with an x plus an x, and then an x, and then plus 2 cubes. So I can get rid of this x and this x. I can't do anything else, so I'm going to see what I have. I'm left with an x equals 2. So that was pretty simple. It gave us the answer here. So there's only one solution, and that's x equals 2. Okay, so that's part A through D. Moving on. Part E has x plus x equals x minus x. So here again, I started to try to plug in numbers. So I had 1 plus 1 equals 1 minus 1. 2 does not equal 0. So now I'm left with, well, maybe 0 will work. So I tried 0. 0 plus 0 is 0, and 0 minus 0 is 0. So I'm like, well, here's another problem where it's only going to be 0 that works. One solution, x has to be 0 for that equation to work. Part F says x plus x equals 2x. Okay, so I drew an equation map for this one. So I have x and an x, and then I have 2x. So it looks like I can eliminate everything and everything. So that means 0 equals 0. So what does that even mean? If you have one side, 0 is always equal to the other side. Let's try plugging in 1. 1 plus 1 equals 2 times 1. 2 equals 2, that works. Let's plug in 2. 2 plus 2 equals 2 times 2. 4 equals 4, that works. Let's try 100. 100 plus 100 equals 2 times 100. 200 equals 200. It's looking like we are going to have infinite solutions here. And it makes sense because x plus x is the same thing as 2x always. So that means for part F that all numbers are solutions. So if you're ever using an equation map and you notice that this side is equal to that side, you know that all numbers are solutions. Always. Right, part G says x times x equals x squared. So this one, I can look at it automatically, and I know all numbers have to be solutions because x times x is the same thing as saying x squared. So if I plugged in a 4 times 4 equals 4 squared, 4 times 4 is 16. 4 squared is just 4 times 4, which is 16. And if I want to double check one more, just to make sure, let's do 10. 10 times 10 equals 10 squared. 10 times 10 is 100. 10 squared is 10 times 10, which is 100. So here we go. All numbers our solutions here. Finally, part H. X minus 1 equals X. And I'm noticing if I plugged in anything for X and I minused 1, it would never give me X. It's always going to be 1 less than X. If I did 1 minus 1 equals 0, well, 1 doesn't equal 0 because this needs to match this. So if this matches this, then it works, but 1 doesn't match 0. Let's try another one. Let's try 100. 100 minus 1 equals 99. 100 doesn't equal 99, so that wouldn't work. Try one more for fun. 1,000 minus 1 is 999. 1,000 doesn't equal 999. So there is no solution for X. No number would work for X. Because you'll see that, yes, 1,000 minus 1 is 999, but we're focusing on this X matching this X, and it doesn't. So that means that it's not going to work for us. And that is the last problem for 6-116. Moving on, 6-117. And skip 6-117. We're going to move on to 6-118. 6-118. All right. Use the equation, the one that gives you to complete parts A through C. I'm going to write down the equation at 8 plus x plus -5 equals -4 plus x plus 7. And there's our equation. It wants us to build it on an equation map, so I'm going to quickly do this. I hope maybe I could speed it up if I edit the video. Okay, so I have an x. I have 1, 2, 3, 4, 5, 6, 7, 8, and those are all filled in because they're all +8. That's also filled in. It's a positive x. 1, 2, 3, 4, 5. There's -5. We have 1 positive x here. We have 7, 2, 3. Positive, 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 positive. 4 negative. 1, 2, 3, 4. Okay. Now we need to simplify it as much as possible. So it says record your steps and what you see when you've simplified it fully. Draw a picture of your final mat. So let's simplify. I see a matching x on both sides, so I'm going to simplify there. I'm going to match up my positives. So I have 7 positive, 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Then I'm going to match up 4 of these. 1, 2, 3, 4. Now I'm left with a +1 and a -1, which can make a 0. So I'm going to just circle those to make a 0. And I'm not left with anything. I got a 0 and a 0. There's nothing on the mat now. So here's my steps. I removed x's. I removed -1s. I removed +7s, and I made a 0. And there's nothing left on the map. So now it says, have each member of your team test a different value for x in the original equation, such as x equals 0, x equals 1, x equals -5, x equals 10, what happens in each case. So that's what we're going to do. I'm going to erase the equation map. And we are going to, for part B, test some values. So let's plug in 0. Let's plug in 0 for 8. x, 8 plus 0 plus negative 5 equals negative 4 plus 0 plus 7. 8 plus negative 5 is 3. Negative 4 plus 7 is 3. So it looks like 0 is a solution. Let's try positive 1. Yep. So 8 plus 1 plus negative 5 equals negative 4 plus 1 plus 7. 8 plus 1 is 9. 9 plus negative 5 is 4. Negative 4 plus 1 is negative 3. Negative 3 plus 7 is 4. So that is also a solution. So if I'm noticing, the equation looks like it's always going to be equal no matter what number you put in. So that means that if this is going to always be equal to that, no matter what number, for part C, it says, are there any solutions to this equation? If so, how many? All numbers are solutions. So that means there's an infinite number of solutions for that equation. Infinite. Forever. Goes on forever. And the last question, 6-119. Gives us another equation. And the equation is x plus 2 equals 2x. Equation map first. We're doing the same procedure as the last problem. So let's quickly draw it. X plus x, positives, plus 2, and 2x. Okay, so let's do our steps. What we can do first is I'm going to remove 2x from both sides. And I'm left with 2 and 0. So that means 2 equals 0, and that's not true at all. So that means that's not going to work. So it looks like there's going to be no solutions. But now it wants us to plug in values again to make sure. So I'm going to plug in 0 for x, and this is part B. So 0 plus 0 plus 2 equals 2 times 0, so that's 2 equals 0, does not work. So 0 is not a solution. Let's try 1. 1 plus 2 equals 2 times 1. 2 plus 2 is 4. 2 times 1 is 2. Nope. Try negative 5. Negative 5 plus negative 5 plus 2 equals 2 times negative 5. Negative 5 plus negative 5 is negative 10. Plus 2 equals negative 10. That looks wrong. Negative 10 plus 2 is actually negative 8. And that's negative 10. Nope, doesn't work. So I'm going to safely assume that the sides are never going to be equal no matter what number you put there. So it says, did you find, for part C, any values for x that satisfied the equation for A? I'm going to say no. It says when there is an imbalance of units left on the mat, such as 2 equals 0, what does this mean? Is x equals 0 a solution for that? So if we have a mat and we're left with 2 on this side and 0 on this side, what does that mean? Well, we've confirmed that that means that there are no solutions that would make the equation true. So it means no solutions. And it says, is x equals 0 a solution to the equation? And we've already looked at that, and it is not. No, 0 is not a solution. Okay, so we've learned about this new thing about equations having either one solution, no solution, or infinite solutions. And I'm just going to put a quick little summary of what they look like. So if x equals x, So if sides are equal, if both sides are equal, there are infinite solutions, or all numbers are solutions. If you get x equals something, so let's just say 2, if you have an equation mat and you're left with x equals 2, that means there's only one solution, and the solution is 2. If you come up with 2 equals 0 on your equation mat, 2 can never equal 0, so there are no solutions in that case. So there's 3 things here. If both sides are equal, all numbers are solutions. If x is on one side and a number is on the other, you have one solution. And if you come up with a number on one side and a different number on the other side, you have no solutions to your equations. And that's kind of a summary of what we just learned. And you do need to know this for 8th grade, because 8th grade, we have been through this already in one of our lessons. So it's kind of, we're introducing it now, and we're going to get a little bit more work going on into next year as well. And that is 6.2.6. Thanks for watching.